All right, thank you for joining us today. And in this video, I'm going to show you all the tricks, all the things that you need to succeed in Math 101, Algebra and Trigonometry, right? So exam is approaching and you need tips, right? So mostly Math 101 comes with objectives, right? And what I'm going to do is I've been a student in UCC before and University of Cape Coast before, and I know the system how to succeed, right? I was overall best student class of 2022, 2023. So I know how the system works, how I succeeded in the mathematics department, and how, I was able to make A in all my math courses. It's not difficult, it's very simple. All you need is the techniques. Right. So with how am I going to succeed in Math 101? It's very simple. Now, first thing that you need to do is, I know you have some textbook called Algebra and Trigonometry. The first thing to do is learn some formulas, right? So you learn some formulas from the textbook, right? So get some formulas down. When you get some formulas down, it's very important to know formulas because that's one thing about math. Some questions you need formula. If you don't know the formula, you cannot do it, right? So learn some of the examples in the textbook, learn some formulas, get some book, and then write down the formulas. In our next book, which is Math 102, we have compiled the formulas in front of the books for you. So that one is going to be easy for you to learn. Also, what you need to do is learn your notes, right? Make sure that the notes that they've given you are the examples you've gone through. It's good for you to understand whatever it is taught in class. When you were able to understand everything taught in class, it is the best way for you to go. Now, let's assume that you've done that, but it was not also working. What's the next step that you are going to take? The next step that you are going to take is the what is called the Merblin series, right? So the Merblin series, which in short we call it MERB series, right? The new name that is coming up, MERB series, right? So MERB series was designed by myself. It's a book that when I came to the university, I was like, okay, let me do something to help students, right? It has been in the system for almost 5 years. It's helping students a lot. Now, the idea is that sometimes they repeat past question. It is not the case that they are going to repeat the past question in the upcoming exam, but the idea is that mostly you get some of the question repeated, right? So what do you need to do? You need to make sure that you grab one of the Merblin series and you go through all the practical examples that it is giving, the exams that's given. Make sure you solve them. But the idea is that when you are solving the MERB series or the Merblin series, the idea is that, you see, we've given you not just that, since the question is objective, not just that we've given you A, but we've given you, like, let for example, this one like this, we are not just giving you A, but we are giving you the procedures, like the one that you need to go through so that you'll be able to understand, the material, how we had the A, how we had the B. So that is one thing that you also know, you need to learn how to understand the process, how we solve the questions to get the solution, so that when you go and something is changed, if they've changed some value, you should be able to use the same process to do the questions which is similar in the past question, right? So in this video, stay with me. In this video, what I'm going to do is I'm going to take 2023, 2024. So this 60 questions that I'm going to go through is 2023, 2024 exam question. And what am I going to do? What I'm going to do is I'm going to show you how to tackle objectives questions, right? We have a way, everything that you do, you need to have a way of tackling, each question that is going to be given to you. So when you are here with me, you will see that each question that I'm going to take will have a new way of looking at the question and how I'm going to tackle the question. All right, so let's start with this question one here. So which of the following asymptotes would the graph of the function have? right? So I'm looking at this function here. The first thing that I need to look at is my options, because this is objectives. So I don't just start working the thing. So I look at my options, I see vertical asymptote, horizontal asymptote, oblique asymptote, like combined, and no asymptote. So no asymptote, the first thing that I need to do is, when you talk about no asymptote, mostly it is when the function is a linear function. That's when we have no asymptote, or maybe we can cancel what is on the down here. Then we don't have any asymptote. So the first thing that I'll think about is, okay, let me see if there is no asymptote. That's the first thing, because you don't want to be in a rush. So what am I going to do? I know that my f of x can be written as this one here. I can factor the top, I can factor x out. So I can write this one as x out, 3x minus 2 divided by 2x plus 1. So I can see that now I cannot cancel the denominator. So it means that this option is out. No asymptote. It means that there is an asymptote. And since this one option is cancelled out and it's left with option A, B, C, it means that two of them is going to be present, because the horizontal asymptote and oblique asymptote is like the one comes if we have horizontal asymptote, it means that we don't have oblique asymptote, and when we have oblique asymptote, we don't have what? Horizontal asymptote. So it means that definitely, since the function is in the form of a fraction or a fraction, we are going to have a vertical asymptote. Why? Because we were not able to cancel the denominator. So that's one thing that you need to know. So basically it means that this guy's C2 is out, because there is no even way that we can have oblique and horizontal asymptote in a function. So C is also out. So you see the way I've taken D out, I've taken C also out, because oblique and horizontal asymptote cannot repeat at the same time in a function. So C2 is out. So now the idea is that I know that since this is, the idea is this is a rational function, I'm going to have a vertical asymptote. So now I need to figure it out if I have horizontal asymptote or oblique asymptote. So now my option is A and B. So if, let's assume that I even don't know and I just want to do like doing guess, I can choose from A or B and I'll get the answer right, because now I'm taking C and D out. So what is vertical asymptote? Vertical asymptote, I'll show you how to do that, so that if you don't know, it will help you. Vertical asymptote is picking the one at the denominator, setting it to 0. So vertical asymptote here is like 2x plus 1 is equal to 0. Then I find for x. So I'm going to have 2x is equal to minus 1, and x is going to be minus 1 over 2. So this is my vertical asymptote here. This is my vertical asymptote here. So I have a vertical asymptote. Now, how do I check for horizontal asymptote and oblique asymptote? We have some rules that governing this function. So now that we cannot cancel, I will expand it back to the function here. So this is going to be 3x squared minus 2x divided by 2x plus 1. Now, with horizontal asymptote, we compare the leading coefficient. I said the leading coefficient, the leading degree. So on the top here, the degree here, the leading degree here is 2. Down here, the leading here is what? 1. So you can see that we have the degree on the top to be 2 and the one at the down to be 1. So here we are going to say that there is no horizontal asymptote, because the degree of the numerator is greater than the degree of what? The denominator, because this is 1. So it means that if that happens, then we are going to have what? Oblique asymptote. There is no horizontal asymptote. We have horizontal asymptote when the degree of this is the same as the degree of this, or the degree of this is less than the degree of this. So for example, a function that we can have a horizontal asymptote is a function where we have like something like 3x squared divided by, let's say, 4x to the power 3. So the degree here is less than this. So we have a horizontal asymptote, and mostly we are going to say that since this is less than this, the horizontal asymptote is 0. Then another one is when the degrees are the same. When the degrees are the same, then what you are going to do is the horizontal asymptote will be the coefficient of the leading degrees. So here the horizontal asymptote is going to be 3 divided by 4. So note that. So with the idea of the degree of the top greater than the degree of the denominator, it means that there is no horizontal asymptote. So it means that here our option is going to be B. So you see the way I'm doing the analysis? try to understand the materials, try to understand each of them, eliminate some of the options from the objectives, and be free with the other options that you are going to also go through. Right. So that is the idea with question 1. You will see that maybe you go to question 2. The idea of question 2 too is going to be different. So each question and how you are going to what? Approach them. I love doing integration and differentiation. Why? Because mostly when I'm doing integration and I know how to do differentiation, I just pick the final solution. I differentiate and get what is the question, and then I pick my solution. I'll show you when we are dealing with further calculus, right? So now I'm going to go through this question. Now, this question is find a sum. So when I hear find a sum, I know that this is sequence and series. So as soon as I see that this is a sequence and series, the next thing that I need to do is, okay, what are the formulas, sequence and series? So that's the reason why I was talking about finding formulas. So now what can I do now? I'll try and rewrite this, series and see, right? Because now we want to find the sum of the first 7 terms. So what is the first one? We have 1 over 2. Now how can you write 1 whole number 1 over 2? It's the same as 3 over 2. The next one will be 9 over 2. The next one will be 27 over 2, and it goes, right? So now we want to now look at the function, whether it is a GP or it is AP. GP is the geometric progression, and AP is the what's the AP? Arithmetic progression. Good. So that is the idea. So now we know that the first term is always A. So without even thinking whether it is AP or GP, we have A. And remember, A is always the U1, which is 1 over 2, the first term here. Now we need to check R. We need to find our R, but we know that R can be AP or GP. When it is AP, then we pick. So now this is U1, U2, U3, U4, right? Going. So if it is AP, then U2 minus U1 should be the same as U3 minus that. So when it is AP, U2 minus U1 should be the same as U3 minus U2 in that order, right? But let's assume that I subtract this from this. It's not going to be the same as when I subtract this one from this. So it means that automatically it's not going to be, you can check it out, it's not going to be what? AP. So I need to check GP, right? So GP is U2 divided by U1, which is supposed to be the same as U3 divided by U2 in that order. So what will be, let's check. What is U2? U2 is 3 divided by 2 divided by 1 over 2, and this is the same as 3 over 2 times 2 divided by 1, and this is 3. Let's pick another one and check if we are going to get 3. Let's pick the U3 over U2, because the one that we just did is U2 over U1, right? So this is going to give us something like 9 over 2 divided by, so I'm just bringing this divided by here, U2 is 3 on 2, so 3 on 2, this is the same as 9 over 2 times 2 over 3, this cancel this, and we are going to have 9 over 3, 3 goes to 9, 3. So you see that they are giving us the same results as compared with the AP. So it means that here we are going to use the GP. Good. So now that we have our A, we have our R, then now we need to remember the formula for finding the sum of what? GP. So what's the formula for finding sum of GP? So you see, I made mention of learning the formulas. So Sn is equal to A, then Rn minus 1 divided by 1 minus this, where our R is greater than 1. So here we can see that R is greater than 1. When R is less than 1, like absolute of this is less than 1, you see that you will swap what is inside the bracket here. You are going to swap them. So when it is the other one, you just doing need to swap them. So now we know A, we know R, and we know N. What is our N? Our N is the number of first term that we are going to do, right? So now our n is equal to 7. We know that a is 1 over 2, and we had r to be 3. So all we need to do is we just need to do substitution and we are done. So what is 1 over 2? R is this to the power 7 minus 1 divided by 3 minus 1, right? So what are we going to get at the end of the day? We can put it in the calculator because I will know, because of the questions are 60, I'll just move it very fast, but I will just simplify the top. So this is going to be 3 to the power minus this divided by 2. And when you put it in the calculator, you should get something like 546.5. Right. So let's go and check if we have 5. Okay, so we have that there. So this is C. So this is how we go through the objective. So you see that each question that you are going to tackle, it depends on how you see the questions and then how you need to go through the question. Right. Let's go to question 3. Question 3, the first term of a GP. So this question has made mention of a GP. So we know that we know GP. So the first thing, if I know GP, the first thing that I might even think of is, oh, GP is having like UN to be equal to A, something like this. So because the question made mention of what? GP, underlying the good terms, right? So what's the first thing? Saying that the first term, so we know that, we remember that we said the first term is A, which is the same as U1. And this is equal to what? 9. Then what's the next one? The fourth term is 45. So what is the fourth term? The fourth term is U4, which is equal to, so the U4 is like, now n is what? N is what? 4. So we are going to have AR4 minus 1. So when you look at the A here, which is U1, this one, N is 1. So when I put 1 here, this one is going to be like 0. R to the power 0 is going to be 1. That's the reason why we are having the A, which is equal to what? 9. So this is going to give us AR to the power 3. Right. So now we have, let's say, equation 1 and we have equation 2, right? Because now we want to find the 8th term. So what will be the 8th term? The 8th term will be U8, which is equal to AR 8 minus 1, which is going to give us AR to the power 7. But we know A to be 9. So we can plug 9 there, R to the power 7. So now what we need is we need to find for R so that we can do it. So we can use equation 1 and equation 2 to find for R. Then we just sub it here and we get our results. So now let's find for R. What I can do is, with geometric, mostly we divide, right? So since this is having R to the power 3, I'm going to divide equation 2 by equation 1. So equation 2 divided by equation 1, what are we going to get? We are going to have AR, oops, I think this one is supposed to be equal to, from the question, supposed to be equal to 45. So let me make it equation 2. Good. So this is equal to 45, and we are dividing it by equation 1. So this one will be divided by A, and this one will be divided by 9. Right. So what are we going to get? A will cancel A, so we are going to have R to the power 3. 9 goes to 45, how many times? 5. And then R is going to be 5 to the power 1 over 3, or cubic root of R. So now we can now put R inside our equation here, right? So what can we do? We are going to have 9, 5 to the power 1 over 3 to the power 7. And when you punch this one on the calculator, we are going to have 384.74. So you see here, we need to remember some formulas, like for example this one here, and then we need to know the trick in geometry, like geometric progression, the idea of dividing and then also finding this one too. So you see, each question that we are taking, we have a new way of tackling the question. You get it? So that is the idea. Now let's look at question 4. So question 4 here is the idea that we want to find the 3 partials, right? So let's go to partial fraction, right? So I know partial fraction. Now another way of getting this answer right, the shortcut is picking the answers and trying to finding the common denominator and expressing it into this form. You see that? So that is one way that you can do. Another way that you can do is you can check the denominator and see which one is going to be out. So we have this one here, which is right. This one is repeated, so we need to have x minus 1 and then x minus 1 squared. So even a is out. This one is right because the denominator is right there. This one is no. The option is B. So you see the way I captured the options. I know that since this is repeated, if I write this one, k of x is going to be 5x squared minus 2x minus 19 divided by x plus 3 x minus 1 squared. This is supposed to be a divided by x plus 3 plus b divided by x minus 1, because this is squared, is repeated, right? The rules of partial fraction. So this will be plus c divided by x minus 1 squared. So I was just looking at the denominator and I was able to detect which one is going out. And I had this here, here, but all of this were having plus, plus, was supposed to be minus. So the only option that I'm going to choose here is the B. So you see, this is a long way of getting it, but because of I'm checking the final answers, I was able to even detect the answer before solving it. So you see that when we are doing it together, you are going to spend time solving all this, but I just use this trick to find out that the results here should be B. I just choose it with just a second. I save time to solve another question. So that is the idea of getting know how to what solve partial fractions. But I'll go through the process and we are going to see if it is true. The answer is supposed to be B. And yeah, it's supposed to be B. So because definitely because of the denominator. But I'll go through the process so that if you don't know how to do partial fraction, we can see how we can do that. So this is going to be, when I find the LCM here, so I'm going to have x plus 3 and x minus 1 squared, because this one is already inside this, so I'm going to have it this form. This one will cancel this, so to be left with this multiplying the a. So I'm going to have a x minus 1 squared plus one of this will cancel one of this, so I'm going to have b x plus 3 x minus 1, and I'm going to have c. This one will cancel this, so it will be left with x plus 3. So since the denominator is the same as that, we equate the numerators, right? So that's what we are going to do. So we are going to have 5x squared minus 2x minus 19. So you see, if you don't know how to do it, you see the process that you need to go through before you get the results. Good. So I just use some shortcuts. Sometimes it will not going to work, but you see that always when you know the techniques of solving objectives, it helps you to sometimes figure it out before it is what too late. So let's use the cover up method, right? And then let's see how things are going to be. So when x is equal to 1, you will see that this will go to 0, this one too will go to 0, because 1 minus 1 is 0, 1 minus 1 will be 0. So it will be left with this. So when I plug in 1 at the left hand side here, this one here will be 5, this one will be minus 2, this one will be minus 19. So I'm going to have on the left side, I'm just doing straight, minus 16, which will be equal to, when I plug in 1 here, I'm going to have 4. So I'm going to have 4c, and c will be equal to, when I divide 2 by 4, I'm going to get minus 4. Right. Another way that I can do this is I can cover up here. I can set x to be equal to minus 3 to find for b. So when c is equal to minus 3, then what am I going to get? This guy will go to 0, right? This one too will go to 0. So it will be left with this. So when I plug in minus 3 here, I'm going to have minus 4. Minus 4 squared will be 16. So I'm going to have 16a on the left, 16a on the right rather. Then when I plug in minus 3 here, what am I going to get? 3 squared will be 9. 9 times 5 will be 45. This one is going to give us plus 6. plus x minus this one is going to give us 13, and then minus 13 plus 45 is going to give us 32. So this is going to be 32. I divide through by 16, and I'm going to have this one to be equal to 2. Right, so you can just, we have the solution in the past question, but I'm trying to show you how to be smart, right? Good. So one thing, another way that we can do here is, now because we know C, we know A, we can choose any value that will even make sure that even if this is not 0, since we know C and A, we can find for B. So for me, I'll choose something which is very easy. I can choose S is equal to 0. So when I plug 0 here, I'm going to get negative 19 is equal to, when I plug 0 here, I'm going to have A. When I plug 0 here, 0 here, I'm going to have negative 3. So negative 3B. And when I plug in 0 here, I'm going to have plus 3C. So I know that A is 2 minus 3B. I know that C is 4. So 4 times minus 3 is going to give us minus 12 minus 19. Then when I add this one, I'm going to have minus 10. Move minus 10 here, and I'm going to have minus 9, which is equal to minus 3B. Divide through by B and negative 2, and you're going to have 3, right? So I've gotten B to be 3, A to be 2, and C to be what? Minus 4, right? So let's go and check if the result is right. So let's go through quick and check. So we had A to be 2, right? So I'll just put the 2 here. We had B to be 3, so let's put 3 here. And then we had C to be minus 4, so let's put minus 4 here. So now let's see what happens here. So we can see that the B that we chose, this is right, but this and this was swapped it out. So it means that the option B is wrong, but we can see that from option A that we have the 2, 3, and minus 4, but option A2 will be wrong because this one's supposed to be minus before we can conclude that, yeah, this is the right option, right? So even though we chose B, but we are getting it wrong, this one should be a bonus question because there is no option. If there is going to be option, the best option should be the B here, right? So that is the idea with solving the partial fraction right here. Let's look at question 5. Question 5, we have this one to be equal to this. Find the value of P. So what can I do here? We want to find the value of P and Q. So since this one is like in the factor form, we need to factor this function. So I have 8x squared plus 13x minus 6 is equal to x plus P, and then qx minus 3. Now, one way that you can do is, if you don't know how to do the factorization, you can pick A, put minus 2 here, put 4 here, expand and see if we are going to get this. If you don't get it, you can pick another point, put them in, expand and see if we are going to get it till you get to the last point. So this one is like you need to do extra work, right? Put them in and see what is going to happen. Is that right? So that's the idea. But what you need to do is you can also try to expand this function here and see. So what will be the factors of 8 times 6? 8 times 6 is going to give us something like, I think it should give us something like 48. Yes. So these are, when I multiply this one by this, I'm going to get minus 48. So we need to look for factors of minus 48 that when you multiply, we get minus 48. But when we add them, we get, let me say, is this one supposed to be 48 or 52? Just kind of confused small. Yeah, this one's supposed to be 48, I think so. Because yeah, so that's right. So what we can do here is we can just divide this function into x squared plus 16x minus 3x minus 6, which is equal to our right hand side here. So you see that when I add 16 minus 3 will give me this, but when I multiply this and this, we are going to have what is here, right? So 16 times 3 is minus 48, and then when I add this one, I get what is here. So now let's now factor some things out. So with this one, I can factor 8x out, which will be left with x plus 2. Then here I can factor minus 3 out, which is going to be minus 3 out x plus 2, which is equal to what is on the right. So since this is common here, I can write this one as x plus 2, right? And then 8x minus 3, which is equal to x plus p kill x minus 3. So what can we see? We can see that we have the 3 here, minus 3 here, minus 3 here, right? We have x here, we have x here. It means that these two here is equal to p, and then we have x here, we have x here. So the coefficient of x is equal to this. So it means that p should be equal to 2 and k should be equal to what? 8, right? So you see that if we're doing the expansion, this will be the results here. So when I plug in 2 here and plug in 8 here and expand, I will get what is here. What is the shortcut way of doing this if you don't know how to do this expansion right here? Now let's look at the sixth question. So still be with us, because each question that we are going to take, actually show us the way of answering the question. So you see that we have different type of questions and how we are going to go through them. Now the fifth term of an arithmetic progression is 18. So what is the formula? Un is equal to a plus n minus 1d. So formulas, always important. So since we are talking about the fifth, this one will be u5 is equal to a plus 5 minus 1d, and this is going to give us a plus what? 4d, and we are saying that this is equal to what? 18. Let's say this is equation 1, right? Now the 12th term is 46, right? So I think small mistake here. We'll check and do the correction. So u12 is going to be a plus 12 minus 1d, and this is going to give us a plus 11d, and this one's supposed to be equal to 46, equation 2. So what I'm going to do is I'm going to solve equation 1 and equation 2 simultaneously. But good for us, we can see that this and this are the same. So what I'm going to do is I'm going to do 2 minus equation 1, right? So equation 2 minus equation 1. So what is equation 2? A plus 11d is equal to 46 minus what is equation 1? Equation 2 is this, and equation 1 is 1 plus 4d is equal to 18. So a minus a is going to be 0. 11d minus this is going to give us 7d, which is equal to 46 minus 18 is going to give us 28. And when I divide 2 by 7, I'm going to have d to be equal to 4. So what I can do is I can plug the 4 inside any of the equation to find for my a. So what will be a? Let me use equation 1. A plus 4 times 4 is equal to 18. So I'm using equation 1 here, but my d is 4, so I plug it in. So this will be a plus 8 is equal to 16 is equal to 8. A is equal to 18 minus 16, and a should be equal to 2. So even what is the question? The question is asking us to find the 18th term. So now that we know a and d, we can find the 18th term. So what will be the 18th term? U18 is equal to a plus 18 minus 1d. right, which is a plus 17d. We know a to be 2, we know d to be 4. So you see the nice way of solving it, very nice. So what are we going to get here? Here will be 2, 17 times 4 will give us 68, and this is going to give us 70. Let's check if we have the 70 there. Yeah, of course. And then we get this one right here. Right. So that is how you can also go. So are you noticing what we are doing? Formulas are very, very important. And when you pick the formulas to the process of solving the questions are also very important. How to solve it in a smart way for you to get the answer very quick are also important. Let's look at question 7. So some of the questions I'll just show you the way and then I'll just move because we have 60 questions. We need to move very fast, right? Now, this one we have the function already given to us, and they said how long will take the mass to reach a height of 50, right? So what is the height? The height here is the x. So x is 50, right? Our x here is 50, and then we want to find for time. So that's the t. So now x here is 50. So we're just going to have 50 is equal to 80 of t minus 16t squared. So when I write this one, I'm going to have 16t squared. So I move this one here. Then when I move the 80, I'm going to have minus 80t plus 50 is equal to 0. You can use calculator to punch and you are going to get something like 4.27 seconds. So this one is supposed to be B, right? So some of them are pretty straightforward for you to go through them. Which of the following is true for the quadratic function here? Has a maximum, has a maximum, has a minimum. So one thing that we can also see from here is anytime the function is negative, we have a maximum. So here C and D is out. So what I need to think about is I need to think about A or B, because that is where the function looks like. So for us to look at the maximum value, whether it is 0 or 9, we can use the idea of completing of squares to check if yes indeed that is the results, right? So let's go through completing of squares very quick and see the maximum value that we are going to get, right? Don't forget, this is completing of square is of the form f of x is equal to ax plus h squared plus k, right? So where the k is the maximum value, since this is the maximum value. So let's go and check for k and we can conclude for that. So f of x is equal to minus x squared plus 6x minus 9. Now for us to start the completing of squares, always the coefficient of x squared should be what? 1. So since here is like we have -1, we need to factor -1 out. So when I factor negative out, what will be left? Here will be left with x squared. Here, for me to multiply the minus and get positive, I need to change it to negative 6x. And this one, for me to multiply negative and get negative, I need to change it to positive. So how do you do completing of squares? We pick the coefficient of x, we find half of that, and then we square it. So what is the coefficient of x? Minus 6. I find half of that, or let me write it in this form, half of this, which is going to give us -3. So I'm going to add 0 to this equation here by squaring this here. So I'm going to square -3, right? So I'm going to add, I'm going to subtract, right? So that it's kind of like I'm just taking it out. So what am I going to do? This is going to be minus x squared minus 6x, right? So after I'm done writing the term that we used to get this, I'm going to add plus -3 squared minus -3 squared plus the 9, right? So how did I do that? This one is plus, and this one is minus. So like this is actually 0. So it gives us back what is here, right? So that is what we are going to get. Now, what can we do? This term right here, when I combine it, I'm going to have x minus 3 all squared. Because when I expand this, I will get the term here, right? So that's the idea. So I'm combining this. So I'll pick the x minus the 3 here and square them. And it will produce what is in the middle here. So what is left? Minus 3 squared is 9 plus 9. And this is going to give us minus x minus 3 squared. This is going to be 0. So plus 0. Multiply the minus through, and we are going to have x minus 3 squared plus 0. So let's compare this that we have here. Let me just bring it down and let's compare. So what can you see here? We can see that a is minus 1, k is actually 0. So since we know this is maximum because it's minus, then since it is 0, the final result here is supposed to be a. Right. So that is the idea with this question. Let's look at question 9. Question 9, we want to find the remainder, right? So anytime you want to find a remainder, sometimes we need to use a long division. But let me show you the shortcut way of, doing this. Whenever we are talking about a remainder, it means that this function here does not divide this one exact and have a remainder of 0. It means that we are going to have a remainder of something. So what I'm going to do is I'm going to pick this because this is divided by this. So I'm going to pick x minus 2 and set it to 0 and find for my x, which will be 2. And then I'll say let f of x to be equal to 3x squared minus 4x plus 2. And then I will just plug in the value here. The answer that I'm going to get, that will be the remainder. Because if this is a factor, then when I plug it in, I need to get 0. So if this is it's not a factor, then it's not going to give me 0. It's going to give me a value, which is called the remainder. So I'm going to have f of 2, which will be 2 squared minus 2 plus 2. This is 2 squared is 4 times 3 is going to give us 12 minus 8 plus 2. And this is supposed to be 6, I think. Yes. Is it 6? Yeah, it's supposed to be 6. So here the remainder is supposed to be 6. Instead of you can use the long division too, you are going to get 6. But this is a short way of doing this. Good. Let's look at 10. Describe the graph of the function this. So some of the functions, like some of the questions, you should be able to know whenever I see something like this. Like this is looking at like a circle, but it's not a circle, right? Because the idea is that let's assume that y is equal to h of x. Then what will be y? Y will be equal to root of 1 minus x squared. I square both sides and I'm going to have something like y squared is equal to 1 minus x squared. Move the x to the left side, I'm going to have x squared plus y squared is equal to 1. So you can see that what I have here is like a circle with a center 0, 0 and a radius of what? 1. So actually when I pick the root, it means that now I'm moving from, because the idea is that anytime I pick the root, this one should be greater than or equal to 0. So it's like I need to move from the negative values. I need to ignore all the negative values. It means that when I'm on this x and y plane, instead of having a circle, which is this, because of the root is going to actually making sure that all the y values are what? Positive. So if all the y values are positive, then you know that this here is where the y values are negative. So it means that the graph will actually clear the one under this. And this is what you're going to get. So you can see that this is a semicircle, right? Because of this. Because the y values, which is h, which we are saying that the y value should be greater than or equal to 0. So that's the reason why it is on here. So the y value should be greater than 0. It should be up. So here should giving us a semicircle. It's nice, right? Good. I hope you are understanding them. Good. So let's look at question 11. We have a long way to go, but let's be here with me and let's go see how each question is being tackled. Right. Then now when you finish, you grab your Merblin series, and I didn't even talk about it. Grab your Merblin series and grab your A, right? So that is the whole idea. We have the solution for you, but I just wanted to explain for you to see how we tackle them, because we just write them down and you don't know the explanation to how we go through them. Now, when I was a student, like in undergrad, how I do them. So now here we want to look at the quadratic, right? We want to see if we can find a quadratic here. So this is very simple. So x squared minus x minus 2 is less than 0. So let's do the factorization here. Two values that when I add, I'll have minus x, but when I multiply, I'll have this. It's going to be something like minus 2x and then x, right? So this can be written as x squared, right? Let's say plus x minus 2x minus 2x less than 0. So 1 times minus 2 will be minus 2. And when I add this one, I'll have what is here. With this, I can factor s out and have x plus 1. And then with this, I can factor minus 2 out and have x plus 1 less than 0. So I will have x plus 1, x minus 2 less than 0. So what are the x values? I pick x plus 1 less than 0, and x should be less than minus 1. Did you see that? And then x minus 2 here is less than 0, and x should be less than 2. Did you see that? But we are not done, because our answer here is presented on something like, interval form, right? Is it interval? No. In the inequality form, inequality notation, kind of. I'm messing them up, but it's okay, right? So basically, we need to draw and check it out. But basically, we can see minus 1 is here, minus 2 is here, and we have minus 1, minus 2. So basically, this is how it's supposed to be the result. But let's check this one and check this one too as well. So because of that, let's go to the right procedure. Put minus 1 here, put 2 here. We want to check where the function is. All right. So I'm going to pick any value here, which is like minus 2. I pick any value here, which can be 0. I pick any value here, can be 3. And plug them in and see if it is going to satisfy this equation here. Let's plug in minus 2. Minus 2 here will give us minus 1. Minus 2 here will give us minus 4. So minus minus will be positive. Is a positive number less than 0? Never. So it means that this is not going to work. Plug in 0. 0, 0. This one will be 1. This one will be minus 2. This time this will be minus 2. Is minus 2 less than 0? Yes, of course. It's supposed to be true. Let's check the last part. Put 3 here. You are going to get 1. Put 3, you are going to get 4. 4 times 1 is 4. Is 4 less than 0? Never. So you see that where the graph is supposed to work is in between this. So it means that our conclusion will be minus 1 less than x less than 2. And we are going to have it this way. Right. Good. If you have any question, you can drop them in the comment section too as well, right? Good. So that is how you can also go about it. Now the equation of the line passes through the point, right? Which is parallel to the line this. So when you say something is parallel, right, to a line, it means that they have same slope. They have same slope. So what we need to do is we want to find the equation of the line which passes through this point. So first, what is the equation of the line? Equation of the line is y minus y1 is equal to the slope x minus x1. So x1 and y1 is the point which is given to us. And fortunately for us, we have the point which is x1 and y1. So what can we do? We can just substitute them. So y minus beta is equal to mx minus alpha. Now we need to find the slope. Now the slope here, we are saying that this line is parallel to this equation here. So we can find the slope. And the slope that we are going to find here should be the same as the slope here. So let's find the slope. We know that the slope, the equation of the line is also of the form mx plus c, where this is the slope. So let's make sure that we do this one in this form and pick the slope from there. So x plus by is equal to c. Let's make y the subject. By is equal to minus ax plus c. Divide through by b. Y will be minus a over b x plus c over b. So compare this to this. We can see that our m is equal to what is here? Great. So let's come and plug it in. Y is equal to, the slope is minus a over b x minus alpha plus beta, because I just moved this beta to the right hand side. Do we have the options? No. So we need to expand. Expanded, this is going to give us minus a over b x plus a over b alpha plus beta. So let's see if we have the option. Option A, no. Option B, no. Option C, yes. So the results here should be option C. So you see what I did? We want to find the equation of the line. So first we need to know the equation of the line. We had a point here which is x1, x2. We plug them in. Now we need the slope, but the question said the equation of the line is parallel to the equation here. So it means that we need to use the idea that the property of parallel lines, right, where the gradients are the same. So if I have this line and I know the gradient, then it means that the gradient here too is known. So that is the idea that we were using here. So each question and how you need to, tackle it and how you need to go about it. So you see that if you don't understand the content, sometimes it's very difficult for you to go through. But this book actually shows step-by-step solution that also guides you. So that's why we have the name here, Merblin series, your guide to success, right? We have it there. That helps you to know what you need to do too as well. Let's look at question 13. So question 13 is a reflection. If absolute f of x is equal to this, and then this is equal to, determine the relationship between g of x and f of x. So you see that this one is a reflection here. Since this is plus, when I want to make s the subject, x plus 5 is equal to 0, x will be equal to minus 5. So here on the x-axis, we need to go to the left, because if you pick this, minus is on the left. So another way, as soon as I identify this, I need to look for the x-axis that goes with the left. So 5 down, no. So you see that as soon as I see 5 down, no, out. 5 up, out. 5 we need to the left. So you see that C is like 5 we need to the left in the x-axis. 5 we need to the left. It works. And then we have 5 we need to the right. So now this one is not going to. So I just pick one point. I was able to figure out that the solution here actually supposed to be going with C before even I think about other options, because this one's saying that 5 we need to the left, which is 2, minus we need to go to the left, right? And then this is the y. So if gen of x is equal to y, then y should be equal to 3, which is right here. So this one, it means that we need to move 3 upward. So we see that we can see the upward here. Upward here. So left and then upward before the reflections also comes in. So we are talking about reflections, right? In the x-axis, and then we have the stretch, which is the minus 2 here, which is going to be on the y-axis. So you see, understanding, reading the textbook, understanding some of the structures, and then picking the idea of you understanding the function and then knowing what to do, right? So actually the original function was this, and this is the translation that we need to do. So if I know the graph of this, which I know that this graph here is supposed to be this and this, then drawing this graph is not difficult, because all I need to do is move to the left minus 5. So if I put minus 5 here, this goes up by this, and it's going to stretch it by minus 2, like make it so large that it's going to open, right? So that is the idea. Let's look at 14. which of the following is not a function? So basically, this one, for us to figure it out, we need to just draw some graph, right? So I can pick like my domain, then I'll pick all the x values. But you can see the one which is repeating, and you can just base on that and say that, okay, this is not true, right? But let's try and write them out. So minus 1 0 1 2 2. So I have 2 4 2 3. So I have 3 4. Right, so let's see. Minus 1 goes with 2, 0 goes with 4, 1 goes with 2, and 2 goes with 3. So what can we say? We have many to one function. Do we have many to one function? Yes, it is true. We have many to one function. Let's look at B. B, we pick the x values. So minus 4, minus 2, 0, and 1. Let's look at the y values. We have minus 4, we have minus 2, and we have minus 1. So that's the y values. So we have minus 4 going with minus 2, minus 2 going with minus 4, 0 going with minus 1, and 1 going with minus this. So what type of function is this? The same one to many to one again. So many to one. So you can see that this and this is 1. So many to one function. Let's look at the C. The C is having, let me just try it here. So the C is having minus 2 0 3 5. Then we have 2 3 7. So we have 2 3 7. Let's draw them. Minus to go with 3, 0 goes with 3, 3 goes with 2, right? Yeah, and then 5 goes with 7. So another the same thing, 1 to many again. So that one too is right. So like what is left is the D. So let's look at the D and see what it's going to give us. So basically, if the D is not working out, then there is no option. Minus 5, minus 3, and 4, right? Then we have 0 1 2 3. So we have 5 moving to 0, minus 3 moving to 1, we have 4 moving to 2, then we have minus 5 moving to this one again. So this one is like one to many function. But the idea is that we don't have one to many function. So the answer here is going to be D. Good. Let's look at question 15. How can I do this? Find the oblique asymptote for the function. Now remember we said with oblique asymptote, the degree of the top should be greater than the degree of the down. So let's see, that's the first thing that you need to check before you even start with the long division. So you can see that the degree of the top is actually less than the degree of the down. So it means that with this question, there is no oblique asymptote. There is horizontal asymptote and there is what? A vertical asymptote. So it means that here the result is supposed to be what? D. Because the degree of the numerator is lesser than the degree of the denominator. We have oblique asymptote when the degree of the numerator or the top is greater than this. So let's assume that this one was 4, then there was going to be oblique asymptote. Then we go through the long division and we do it. Let's look at question 16. Question 16, find the sum and product of this equation. So what's the formula for finding sum? So formulas are very important. Sum is equal to minus b over a, and then product is equal to product of root is equal to c over a. So don't forget this is of the form quadratic, like ax squared plus bx plus c is equal to 0. So when I compare with x squared minus 15x plus 36 is equal to, I can see that a is 1, I can see that b is equal to minus 15, and c is equal to 36. So put b, which is 15 here, divided by a. I'm going to have minus 15 divided by 1, which is going to give us 15. C is 36 divided by 1, which is going to give us 36. So which one is going to give us the right answer? D, right. So D is the one which is having the 15 and 36. So formulas are very, very important when it comes with this. Now let's look at question 17. We want to look at the idea of this log function here. So we can use the log property where we have log A minus log B, and we can write this one as log of A over B because of the minus. So that's what we are going to use. So since we have log here, we can write this one as log to the base 3 x4 minus x to the power 3 divided by x minus 1 to the power is equal to 3. Now we also know that if I have something like log of a b is equal to c, then this one can be written as b is equal to c to the power a, right? So it means that what I have here is going to be like this is my b, this is my c, and this is my a. So I'm going to have x to the power 4 minus x to the power 3 divided by x minus 1, which is equal to 3 to the power 3. It's very nice. See, you are enjoying it. So that is how it is. Do more practice and you'll be good with that. So x to the power 4 minus x to the power 3 divided by x minus 1, and this is going to be 3 to the power 3 is 27. Yes. Then x to the power 4 minus x to the power 3 is equal to 27 times x minus 1. So this is like over 1. This multiply this, giving us this, and this multiply that. So we are going to have x to the power 4 minus x to the power 3 is equal to 27x minus 27. And then when I do the arrangement, I get x to the power 4 minus x to the power 3 minus 27x plus 27 is equal to 0. Right. So after getting this, one way of doing this is you can test all the solutions here, right? Because this is like to the 4th power, and trying to figure out all the factors of this is going to be complicated. So what we can do is we can just plug in 1, 3, 6, and 9. So when I plug in 1, so let's assume that this is f of x. So when I plug in 1, what am I going to get? The idea is that since this is equal to 0, then when I plug it in, I need to get 0. So what is f of 1? When I plug 1 in, I'm going to have 1 minus 27 plus 27. This is going to be 0. So 1 is a factor, right? So x is equal to 1 is a factor. Good. Let's pick the next one, which is 3. Plug 3 in, right? Option B, which is 3. Plug 3 in. We are going to have 81 minus 27 minus 81 plus 27. This is also going to give us 0, and we are going to have x is equal to 3 to be a factor. Let's look at f of 6. Plug 6 in here, 6 here, 6 here, 6 here, and when you do that, everything is going to sum up to 945. And last one, let's plug in 9, and when you do that, that one too is going to give us 945. You can check it out. So the one that they are factors that is going to give us the 0 here is x is equal to 1 and x is equal to 2. But you see that the answer just gave us x is 1, 3, 6, and 9. It means that we need to choose one of the solution. But let's pick one. So now we have s equal to 1, s equal to 3 that we need to test. Let's plug in 1. When I plug 1 here and plug 1 here, what actually is going to happen? This is going to be 0, right? And even if I plug in 1 also here, this is going to be also 0. Now remember, the domain for a log function, if I have a log of, let's say, a, the domain for this says that a should be greater than 0. So the value here in the log, for it to be defined, we shouldn't get 0. We should be getting something greater than 0. It means that when x is 1 and we plug it in, we are going to get this function to be undefined, which is not going to be equal to this. So it means that the only value which is greater than 0 is when s is equal to what? 3. So s is equal to 3 is greater than 0. Right? So the idea is that now when I plug in the value here, 3 here, I'm going to have 2, and 2 is greater than 0. When I plug it in here, I'm getting something which is greater than 0. So it means that the function here is going to work when x is equal to what? 3. Good. Let's look at question 18. Question 18. So what is question 18 about? Question 18 is the idea of reusing the indices and then log property, right? So I have log of 5 root of this is equal to x. So what's the property of log b? A is equal to c. B should be equal to what? C to the power what? A. Or supposed to be a to the power c. Yeah, I think so. Yeah, let me see how I did this one here. I think I cleaned the other one. Yeah, so this one's supposed to be c. No, this one's supposed to be a to the power c. Yeah, so this is how it's supposed to be. So I need to make the correction here because it should be the base to the power this. Good. So this is going to give us fourth root of 5 is equal to 5 to the power x. Now, fourth root of 5 can be written as 5 to the power 1 over 4. So based on indices, since the base are the same, we equate the top. It means that the top two should be the same. So our x should be 1 over 4. So what is 1 over 4? 1 over 4 is actually 0.25. So we are going to have this as the option. That's question 18. So you see how you should be able to tackle each question and the process of the way you want to go through. Which of the following sets are equivalent? So you just need to check. So is this and this equivalent? Yes, yeah, equivalent set because they have two elements, right? Is this and this equivalent? Something's equivalent, like, is it true? Let's look at II. Is this equivalent? Yes. 1, 2, 3. 1, 2, 3. Yeah. So this 1, 2 is true. 1, 2, 3. 1, 2, 3. So the option A is right. I is right, and then IV2 is right. So the option here is supposed to be C, right? This is not equivalent because this is 3 and this is 2. Yes. So that is very simple from there. So here you need to understand the word equivalent here. 20. When are two elements or two sets are said to be equal? Okay, so two sets are said to be equal when A belongs to, so you see that when we're proving that A is equal to B, we need to show that A belongs to B and this one too belongs to that, so that we can conclude on that. So the answer here is supposed to be this guy right here. Good. So this one is a relationship that you need to know. Done. The Cartesian product, this is equal to this, is sometimes true, right? So we can just pick sometimes true. Sometimes true. Why are we saying that it's sometimes true? It's sometimes true when, let's say, all the sets are empty. Sometimes true, it is false. So we cannot say that it's always true. When all the sets are not empty, then this is not true. this is not the same as this is not the same as this. And we cannot say never true because sometimes 2 is true, and not sure it's not the best way. All right, let's move to 22. 22, we are looking at the idea that if A belongs to B and C belongs to D, then which of the following is true? So we can see that if that is the case, then A cross B should also belongs to B cross D. So let's see. A belongs to B and C belongs to D. So it means that A is in B and C2 is in this. So that when I cross A and B, A cross B, A cross C, it should also belongs to B cross C. Why? Because A is in B and C is in D. Good. So that's its idea. How did I write this then? Yeah, that's right. So that's the idea. So since A is in B and C is in D, then when I cross A and C, it should also belongs to this. That's the idea. Good. So the best option here is supposed to be C here. Good. Let's look at 23. For A and B belonging to integer where B naught is not 0, a number that cannot be represented in the form this is called the irrational number, right? So this become irrational when you cannot do it in the form of a fraction, right? Okay. So let's look at 24, 25, 26 coming from this guy here, like the preamble that we have there. So the first question is we want to state the domain. So domain are all possible values of x which makes the function defined. So it means that we need to look for the values of the function that make the function undefined, and we exclude them. So this mostly happen when the function is a fraction. It mostly happen at the denominator, right? So we are going to pick x minus 1, x squared plus 1 to be equal to 0. So what can we see? X minus 1 should be equal to 0, s should be equal to 1, but x squared plus 1, since we are on the real axis, there is no real value that will make this one 0. So it means that this is not equal to 0. There's no way x squared plus 1 will be equal to 0. So the domain will be, the domain will satisfy, or x will belongs to all real numbers except x is equal to 1. So when x is equal to 1, that is when the function it is not what defined. So the only option that is going to work out is A, right? All real numbers except 1. Good. How many roots does the function q of x have? So how many roots? So for us to look at the roots, when we talk about roots, and then it means that we look at the values that, like, we are talking about the zeros of the function, right? So zeros of the function is mostly basically like we pick the top and we set it towards 0. So what we can do here is we can look at this and then we solve. We can be tempted and say that, okay, this is 3, so the root should be 3. But what if the function is repeated? So always it's good for you to solve to check it out, right? So you can use calculator to punch this, and when you use calculator to punch 4x to the power 3 minus 12x squared minus 15x plus 50 is equal to 0, because we want to know the root. X will be equal to minus 2 and 5 over 2. And this 5 over 2 here is repeated. So you see that the root that we are going to get here will be 2. 2 roots, because one of them is repeated. So like this one, if you want to express it, this one is going to be x minus 2. No, x plus 2, x 2x minus 5 squared with a multiplicity of 2. So we have just 2 roots, which is going to make the function 0. Good. So don't always assume that, okay, if this one is 3 then I need to have 3 roots. When it is 2, I need to have 2 roots because most especially maybe some of the function will be what? Repeating itself. So I think I did the question 26. The root x equal to 5 over 3 has a multiplicity of 2. So you see that when I was expressing this, x is equal to, let me do it so that you see it, x is equal to minus 2. When I move 2 to the left side, x plus 2 is equal to 0. X is equal to 5 over 2. When I multiply this one, I get 2x is equal to 5. Move it down here, I'm going to get 2x minus 5 is equal to 0. But since it's repeated, I'm going to have this one 2 times, which is going to give us this. So the multiplicity 2 is going to give us 2, which is very nice. Good. Let's look at 27. At 27, we have real numbers here, and then which of the following represent this law here? So this law is actually, kind of C, right? Because it's either A is greater than B is equal to B, or A is less than what? B. So that is the law of trichotomy, right? So that will be the law for that. So we are going to have this. So this one is just knowing it. If you know this law, you should be able to identify this function here. 28. Which of the following statement is true? So which one is true? If I multiply this and this, then A is 1 or B is 1. Is that true? No. Because this one, I know that when A multiplying this one, I can get 1. But you can also see that if A is equal to 1 over 2 and B is equal to 2, then when I multiply 1 over 2 times 2, I will also get 1. So yeah, it is true though, but it does not satisfy for all the equations. Now A times B is equal to 0, then it's either this 0 or B 0. Is that true? It is not true, because actually one of the value 2 can be, like, let's assume that A is 0 and B is 1. When I multiply, I'll get 0. So no, I'm not going to argue with that. Let's look at C. A dot B gives us 0. You see that this is 0, B is 1, or all of them. Good. So this one is okay, because when A is 0, B is 0, when I multiply, I get 0. If one of the value 2 is not 0, then when I multiply 2, I will get 0. So it can be any number. So I think the best option should be C. Good. Should be C. Let's look at 29. We have a long way, like 29, we have like 31 questions more. All right. So this one, we learn how to do absolute value. So what we just need to do here is we need to square both sides, and then we just start with the work, right? And so I will square 2x minus 1 greater than absolute of x plus 2. Square this, square this. We know the property that absolute of this is supposed to be the same as a squared, because absolute should be able to take care of the minus, and square also does that. So this one can be written as 2x minus 1 squared greater than 3x plus 2 squared. Let's do some expansion and see what is going to happen. This will be 4x squared, right? And when I multiply in the middle, I get 4. Oh, it's supposed to be minus 4x plus 1. So this one is like 2x minus 1, 2x minus 1, right? So when I multiply this, I should be able to get this. This one too is like 3x plus 2, 3x plus 2. And when I multiply, I should have something like 9x squared plus 12x and plus 4. So let's group items and then work with some things. See what we are going to get. Right. So I'll move all this to the side. So I'm going to have 9x squared minus 4x squared plus 12x plus 4x, and then plus 4 minus 1 is less than 0. Remember, I move all this to this. So the sign here is like will be 0. So you see that 0 is greater than that, which is the same as this. So I'm going to have, and this is going to give us something like 5x squared plus 16x plus 3 is less than 0. And then two values that when I multiply, I'll get 15. But when I add, I get 16 is 1 and 15. So this will be 5x squared plus 15x plus x plus 3 less than 0. With this one, when I factor 15x out, get this is supposed to be 3. No, this one's supposed to be 3 and factor 5 out. Then this one will be plus 1 out. I get this less than 0. So I get x plus 3, x, 5x plus 1 less than 0. Good. So what will be the x values? X should be less than 3. And then don't forget this is 1. Right? This one here is 1. So 5x plus 1 is less than 0. 5x is less than minus 1, and x should be less than minus 1 divided by 5. So let's look at the option before we even think about what to do next, right? So we have, let's test it first. So we have x is equal to minus 1 over 5. We have 3. Minus 1 over 5 is 0 point something. So here we can pick minus 1. Here we can pick 0, and here we can pick 4. Let's plug in minus 1 inside the equation and see. So when I plug in minus 1 here, this is going to be positive, right? When I plug in minus 1 here, this is going to be positive. This is also going to be positive. Is that right? No. Plug in minus 1 here, and oh, I think this one's supposed to be, oops, this one's minus 3. So since minus 3 should come first, because minus 3 is bigger than minus 1 over 5. So minus 3 minus 1 over 5. So pick minus 4 here, pick minus 2 here, and pick 0 here. So let's plug in minus 4. Minus 4 here, this will be minus, this one will be minus. So there is no way minus times minus is positive. There's no positive is less than 0. So this is out. Plug in minus 2. Minus 2, this one will be positive. This one will be minus. Minus positive will be minus. Minus is less than 0. So this is true. Plug in 0. 0, 0. It will be 3. 3 is not less than 0. So this is not going to be out. So it means that the interval will stay within this. So we are going to have minus 3 minus 1 over 5. Let's check it out. Minus 3 minus 1 over 5. So actually the result is supposed to be, this one's supposed to be minus. So the result is supposed to be A right here. Good. 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 All right, let's look at question 30. Question 30, let's see what we are going to get. So we want to simplify this. Oh, this is nice. Log this. Now how can I express this? 81 can be expressed as 3 to the power 4, right? Plus log of 4. 64 can be also expressed as, I think, 4 to the power 3 plus 6, and this one can also be expressed as 6 to the power 3. Right. This is the same as third law of log. This one can come down, so 4 log 3 base 3 plus 3 log of 4 plus 3 log of 6. So what are we going to get for this? This will be 4 times 1, because we know that when the base is the same as this, we get 1. Plus this one too is going to give us 1 plus 3 times 1, because 6, 6, 4, 4, 1, 8, 3, 3. So this is going to give us 6, 4. So this is 4 plus 3 plus 3, and this is supposed to be 10. That's very nice. Good. So tricks is working out for us. Yes. And if you have a calculator, you can just punch this one on the calculator and you are going to get this one straight away. Let's look at 31. 31. Okay, so we have a triangle. So this is not right angle triangle, this is triangle. So something like this. Right, so we have A, B, C. So what will be angle? This will be the angle A. Do you have angle A? No, we don't have angle A here. Do we have angle B? So let's assume that beta is angle B. Now they are asking us for angle B, so let's look for angle B. We are looking for this one. So we know that the A side, so let's assume that the A side is 7. The B side, okay, so let me do it this way. Let me draw it here again. Let's assume that this is A, this is B, and this is C. So the B here will be the angle here. So here what we need to do is we need to use the cosine rule, right? What's the cosine rule? Cos of B will be equal to A squared plus C squared, right? Minus B squared divided by 2AC. So remember this formula here, right? So this formula here is mostly we write it as A squared plus C squared minus B squared is equal to 2 AC cos of B, right? But the idea is that since you are making cos the subject, I divide 2 by 2A and I have this form. So what I need to do is I need to plug in A. What is A? From the question, A is 7. So 7 squared. C is 8. So 8 squared. And B is 6. So 6 squared divided by 2 times 7 times 8. So I'm going to have 77 divided by 112 cos of B. So B will be equal to cos inverse of 77, 112. So when you do it, approximately we need to have 47 degrees, which is B. So what did we use here? We use a cosine rule when it is the triangle sides. Simplify this. Oh, that's nice. So we have x to the power 3 y divided by y to the power 1 over 3 x to the power minus 2. So how can I write this? I have x here, I have x here. So I have x to the power 3. When it is down here and you are moving it up, the minus here changes to, like, we need to subtract, right? So this was going to be minus 2, right? And then times y to the power 1, because this is 1. When I'm moving the 1 here, it needs to be minus, so it's going to be minus 1. So this will be x to the power 3 plus 2. 1 minus half is half. So this will be x to the power 5. Half is the same as root, so this one is root of y. So the answer is supposed to be A, which is right here. So it's just a simplification that you just need to do. And then you are done. So this is supposed to be 5 here. 3, 3 is, we have something like this. So which of the following geometry sequence has a common ratio of minus 3? So this one, you just need to be picking them and checking, right? So he's talking about geometric. So you be like, okay, 9 divided by this, is it the same as 3 divided by this? If it is not, you come here. Minus 1 divided by this, is it the same as 3 divided by this? Or 9 divided by this? If not, you move to the next. If not, you move to the next. Is that right? So let's check which one is going to give us 3. So 9 divided by this, absolutely the numerator is less than the denominator. There's no way we are going to get 3. Like minus 9 divided by 27. It's not true, right? But let's look at what is here. Minus 1 divided by 1 over 3. This is the same as minus 1 times 3 over 1, and this is minus 3. That's good. Let's check the next one. The next one will be 3 divided by minus 1. So 3 divided by minus 1. This is also minus 3. Let's check the next one. Minus 9 divided by 3 is also minus 3. So indeed, this result here should be this. Right. So that will be the results for the geometry series, which is given as C. Which of the following is not an equality property? The one which is not equality property here is probably the distributive property here. Because we have the symmetric, we have the reflective, and we have the transitive property. Okay, let's look at question 35. So we have sine A, we have cos B. They are the angles in the first quadrant. Then we want to look at finding this. So the first thing that I'll do is, okay, we know that cos A minus B is the same as cos A cos B. This is minus, to become plus sine A sine B. So if you don't know this identity, it means that you will find yourself, I don't know how you are going to work it out, but you find yourself, not knowing what to do. But another way that you can do here is, here you can pick sine inverse of this and get A, pick cos inverse of this and get B, and plug it in here. So like if I want to do this in other way, I'll have it like this, but maybe it will give you the approximation. So this one will be A is equal to sine inverse of 3 on 5, then B will be equal to cos inverse of 24 over 25. Then I'll plug it in, cos of sine inverse of 3 on 5 minus cos inverse of 24 over 25. Then I punch the whole of this in the calculator, which is going to give me approximation. So maybe I can write the function down. If it is point, I write everything down. Then I pick my calculator to check this one, the one that is going to give me the exact value here. Then I just pick it out. So that's another way of going through without going to what I'm going to do. But the other way that you need to go through and become successful, but this is objectives. So this is a smart way of, actually getting the solution. But I just wanted to show you how to do it. So since I know that this is equal to this, I know that we are in the first quadrant and sine, cos, everything is positive. So I'm going to have this. So sine is opposite. So since I'm putting opposite there, it means that the angle should be here over hypotenuse. Cos is adjacent. So if I put B here, 24 will be here and 25 will be here. So I need to know what is here and I need to know what's here. So we can use the idea of Pythagoras theory to do that. So Pythagoras theory says that opposite squared plus adjacent squared is equal to hypotenuse squared, and A will be equal to 4 from here, and here to opposite squared plus adjacent squared is equal to 25 squared. And solving for B, we are going to have something like 7 here. So what can we do here? We need cos A, cos B, right? So what is cos B? Cos B is already given to us, what is 24 over 25, but we need cos A. So since we need cos A, we need to come here. Remember now A is equal to 4. So what will be cos A? Cos A will be adjacent over hypotenuse. So we are going to have 4 over 5. and then we need sine b. We need to come here. Sine b is opposite over hypotenuse, so 7 over 27. So sine of b will be equal to 7 over 25. So what are we going to get at the end? We are just going to do substitution, and then we are done. What is cos A? We found out cos A is 4 on 5. What is cos B? Cos B was given 24 over 25. Plus, what is sine A? Sine A is given 3 on 5. And what's sine B? Sine B is 7 over 25. And you do justice this on the calculator, you're going to have 117 divided by 125, which is going to give us a B here. So you see the way I did it. I need to know the expansion for this. Then when I'm done, I need to use the angles here, draw it, and find for my other side, so that I'll be able to find for, I have sine A, but I don't know sine B. So I can use this one to find sine B. I have cos B, but I don't know cos A. Then I use this one to find cos A. But another way that I show you is the first one. You can just do it on the calculator and then you are done. Let's look at 36. 36, we know that we can express sec. Sec is 1 over cos, right? And then we know that tan is sine over cos. So now we have sec divided by tan. So we are going to have 1 over cos theta, right? Which is going to give us the sec divided by, so the divided by, I'll do it like this. Divided by tan is this, which is going to give us sine theta divided by cos theta. Then reciprocate this, you are going to have cos theta times 1 over, cos theta divided by sine theta. Cos cancel this, and when I multiply them back, I'm going to have 1 divided by sine theta. But we don't have 1 divided by sine theta there, but we know that 1 divided by sine theta is actually equal to the cosecant, right? Cosecant of theta, and cosecant of theta can be written as CSC theta. So the answer here should be D. Wow. Now let's look at 37. So we are picking all the pictures here. Here we want to know the cosecant of what? B, right? But for us to know the cosecant of B, this is what we need to do. We need to actually draw the right angle triangle. Then we put A here. Let's assume that here is B, here is A, here is C, right? So remember, if this is the angle for sine A, sine is opposite over what? Hypotenuse. So let's put here to be B, right? Which will be the distance. So let's use Pythagoras theory to find, let's say, our t here, or if we put x here. So x squared plus root of 3 squared is equal to 2 squared, which is x squared plus 3 is equal to 4. X squared is equal to 1, and x is supposed to be 1, right? So we get our x to be 1. So in place here, we are going to be 1. But remember that there is a relationship with sec, cosec. We just learned it, that cosec B is the same as 1 over sine B. So what is sine B? Sine B is opposite over hypotenuse. So now opposite for B, angle B is 1, and this is 1. So I'm going to have 1 over 2. So we place that 1 divided by this divide here, 1 over 2. So this is 1 times 2 over 1, and this is supposed to be given as 2. So we have 2 right there. So you see, it's very nice when you understand what you are doing. Very simple. You just go very fast, knowing the the relationship with tricks and those kind of things. Now let's look at 38. If one of the roots of the equation is -2, what is the other root? So this is quadratic, and it's either we get a repeated or we get another root, right? But the idea is that we are saying that if one of the roots is this, so it means that one of the two x equal to -2 is a factor. It means that if I let f of x to be equal to 2x squared plus 10x plus k and plug in -2, I should be able to get 0. So it means that f of -2 is equal to 0 because it's a root and it should give me 0. So it means I'm going to have 2 minus 2 squared plus 10 times -2 plus k to be equal to what? 0, because I plug in -2 in here and this one should be 0. -2 squared is 4, so this will be 8 minus 20 plus k is equal to 0. This is like -12, yeah, I think, plus k is equal to 0, and k should be equal to 12. So now that we found the k, we plug in the k, and then now we need to find the other root. You see how it's going to be. So now we are going to have 12x squared plus 10x plus 12 is equal to what? 0. So now we need to solve this to make sure that now we get the other root. Now the good thing is I can divide 2 by 2, so I have x squared plus 5x plus 6 is equal to 0. Let's find the factors. So two values that when I add, I'll get 5, but I multiply, I get 6 is 2 and 3. So x squared plus 2x plus 3x plus 6 is equal to 0. With this, I factor s out, I get x plus 2. With this, I factor 3 out, I get s plus 2 is equal to 0. So I'm going to have x plus 2, x plus 3 is equal to 0. So what are the values? S plus 2 is equal to 0, s is equal to -2. So you can see that the -2 is the one that they gave us, which is true. So the other factor will be x plus 3, which is equal to 0, and x should be equal to -3, which is the other factor. Very simple. Good. All right, let's look at 39. We can use indices here. 1 over 3 can be written as this. So I'm going to write this one as -3 to the power -1, 4x minus 1 is equal to 3x minus 1, right? And what can I do now? I multiply 2 by the minus here, 2, and then I have 3. So when I have -4x plus 1 is equal to 3x minus 1. The base are the same. It means that we can equate the top, the powers. I move 4 here, I move -1 here. So I'm going to have 1 plus 1 is equal to x plus 4x, 2 is equal to 5x, and x should be 2 divided by 5. 2 divided by 5 should be a. Good. We are almost done. We have like, with this one, when you are done with this one, you have like 20 more questions to go. Keep it up, keep it up. So this is one equation which we have something like 2 absolute of -x plus 4 greater than 10, right? So what do I need to do? This is absolute, so I divide 2 by 2 first. -x plus 4 greater than 10, right? Sorry, greater than 5, because I'm dividing 2 by 2. Then what I said is, since this one is just one sign, we can just actually say that this is plus or minus x plus 4 greater than 5. So I pick the positive sign. So I'm going to have -x plus 4 is greater than 5. And then guess what? I have -5 is greater than, when I move it, I get this one to be 1, right? Because when I move this one, I get 5 minus 4. Then I divide 2 by -1, divide 2 by -1. When I divide 2 by -1, the sign changes to this. So this is the positive sign. Let's look at the negative sign. So the negative sign is going to give us -x plus 4 greater than 5. So when I multiply the minus 2, I'm going to have x minus 4 greater than 5. Move the 4, x should be greater than 5 plus 4, and s should be greater than 9. So what can I do here? Put my minus 1 here, put my 9 here, satisfy. Minus 2 can be here, 0 can come from here, and 10 can come from here. Let's plug in minus 2 inside the equation and see what is going to happen. Okay, so when I put minus 2 here, is minus 2 less than minus 1? Or let me plug it here. When I plug in minus 2 here, I'm going to have minus will be positive. So this one is going to be 6. 6 is greater than this, which is true. When I plug in 0 here, is 4 greater than 5? No. We can also check the same 0 value here. When I plug in 0 here, it's minus 4 greater than 5? Nope. If I pick 10, 10 minus this is going to be 6. Is 6 greater than this? Yes. So what will be the interval? It means that here all the x values are less than minus 1, all the x values are less than minus 1, or all the x values are greater than 9. So all the x values are greater than 9. So this is what you need to get. And the answer here will be all the x values are less than 1, but all the x values are also less than 9. Is that supposed to be D? No. One of the signs is supposed to change. Because what can I say this? All the x values here are like 10, 11, so they are all greater than 9. So for us to say that this is the right answer, this is supposed to be greater than, good. This one's supposed to be greater than 9. All right. Sometimes typing mistake, so we will make sure we check all the corrections from there. Let's look at 41. We are almost done. 20 more questions to go. So 21, anytime I have a trig function like this, I try to draw my what is called right angle triangle. I put my theta here so that I can know my opposite and then my hypotenuse. So I can put A here and find for A, right? Yes. So 5 squared plus A squared is equal to 13 squared. And I'm going to have A, when you solve this, I'm going to have A to be 12, right? So kind of something that I need to do, right? So what can I do again? What can I do? I'm looking for sine of 2 theta. Sine of 2 theta can be written as sine of theta plus theta, right? And sine of theta, let's do the expansion. This will be sine theta cos theta plus cos theta sine theta. They are all the same, so this is going to give us 2 sine theta cos theta. So we have sine theta, but we don't have cos theta. But since we know A, we can have cos theta. So what will be cos theta? Adjacent over hypotenuse. Adjacent is 12 over 13. Do the substitution, you get 2 times. What was sine theta? 5 over 13 times 12 over 13. And this should be equal to 120 divided by 169. Good. So D right here. Good. So you see the trig functions, when you are learning them, you need to learn the identities and the properties very well. So it means that here, okay, what other way can you do this one too? Okay, so one thing that I can also do here is I can, since it's a objective, I can just I can just look for theta, which is equal to sine inverse of 5 on 13. Then the results that I'm going to get, I'm not going to do anything on the calculator, and I just point 2 times answer on the calculator and press equal to. It's going to give you, if it is in the form of point, you write all the points, then you try to enter this on the calculator, change it to the decimals, and you see which one is going to satisfy, and you see that the D is going to satisfy, and you pick it from there. That's the shortcut way of also doing this. Now let's look at this. If sine A is less than 0 and cos A is also less than 0, in which quadrant does the angle A terminate? So let's look at quadrant. So when you are talking about the three quadrants, we have first quadrant, second quadrant, and third quadrant. Here, all of them are positive. Here, sine is positive. Here, cos, no. Here, tan is positive, and here, cos is positive. So if sine is positive and you are moving, you see that this is positive, this will be positive. But when we get here, because in this third quadrant here, it's only tan which is positive. It means that sine is negative and cos is also negative. So we are going to terminate in this third quadrant here, right? Because in the third quadrant, sine and cos is what? Negative. So we are going to just terminate here. I know that here sine and tan is negative, but for us to get to fourth quadrant, we need to get here first. Good. Let's look at 43. So what we can do is, this one is very simple. Just plug the value in and then you just go straight away and then you just pick it from there, right? So let's just pick one and just plug the value in. So here the smart way is, let's plug them in and see what you are going to get here. So when I plug -4, so absolute of 3 times -4 will be 12 plus 5 minus 8. Let's see if we are going to get -1. So this one will be absolute of, this is going to give us 12. -12 plus 5 is going to give us -7. -7 absolute will be 7 minus 8, and this is going to give us -1. So it means that indeed this is equal to -1, and our solution is supposed to be A. Just plug it in and then we are done. We can also do the proving by solving this, and you will see that x is equal to -4, which does not need any calculation since this is objective. So I'll check it out from there. Let's look at question 45. So question 45, we want to find what is the third term in the binomial expansion this. So for us to find the third term, what we need to think about is, always we need to think about something like of the form a plus b to the power n, right? And when I'm equating this one to x minus 2y to the power this, we can see that a is equal to x, b is equal to -2y, and n will be 6, right? So now what are we going to do? We are going to use the idea that n combination r of a n minus r be this. So since we want to find the third term, third term is when, so the third term from this one is when x is to the power 4, right? Because the first term is going to have x to the power 6. The second term is going to have x to the power 5, and the third term is going to have x to the power 4, right? So since the third term is going to have x to the power 4, then we need to choose our r to be 2. So if r is 2, then now we are going to have 6 combination 2. What is a? A is x, n is 6 minus 2, and what is b? -2y to the power 2. So what is 6 combination 2? That is 15. Then x to the power 4, and then this is going to give us 4y squared, and then when I multiply 15 by 4, I get 60, x to the power 4, y to the power 2. Good. So for us to get the third term, then we need to pick this so that we get the third term. So we know that the third term will be at when x is to the power 4. because the first term will be x to the power 6. We reduce it by 1. You move to 5, reduce it by 1 will be 4. So since our n is 6 and we want to get it by 4, we need to reduce by 2, which is going to give us the r, and we are going to have something like this. So because of that, we are going to have something like a, I think so. So it will be the solution there. Let's look at 46. So 46, we have the right angle triangle, and then we have AC to be 24, BC to be 34, and we want to find the secant of B. So let's try and draw something like this. C is here, B is here, and this is here. We said AC is 24, BC is 32. We need to find the C here. So let's use Pythagoras theorem. 24 squared plus 32 squared should be equal to 60. C squared. So when I do this and solve, my C is supposed to be 4. T, right? Using the Pythagoras theorem. Now what are we looking for? We are looking for sec B. We know that sec B is the same as 1 divided by cos B, right? So let's assume that B is here. So what will be the angle? Since the angle is here and we need cos is adjacent over hypotenuse. Oh, I'm just lost. What's the question looking for? Sec B, right? Okay. So I'm going to have it that form. So it will be this divided by this. So I'm going to have 32 over 40. So cos B will be equal to 32 over 40. And then it means that sec B will be equal to 1 divided by the whole of this, which is going to give us 40 divided by 32. We have 40 divided by 32. Then I don't think that will be the right one. I think this one's supposed to be A. I think so. Yeah. This one's supposed to be A. Like we are looking for sec A. Yeah. I think that's supposed to be the right one. So sec A, it means that this just changes to A. This changes to A. So what will be cos A? Cos A is opposite over hypotenuse, which is going to be 24 divided by 40. 24 divided by 40, which is the same as 3 over 5. And then when I want the sec, is just turn it around and I get 5 over 3. Okay. Yeah. So that is what we wanted to get. We are almost done. If one of the roots of the quadratic equation is 3, the product of the root is 15. What is the value of B if the equation is of the form this, where C is 0, what is equal to the where and A is equal to 1? So we know that one of the roots is 3, and we know that the product root. So what is the product of the root? Product of the root is equal to C over A, right? Now AS squared plus this plus C is equal to 0. We know that A is equal to 1, so it means that here will be C divided by 1 and the product will be C. But the question said the product of root is 15. So it means that the product of root here is equal to 15. So it means that C is equal to 15. So we know C, we know A. Now we need to look for B, right? So we are going to have something like, since we know A, we are going to have our equation to be x squared plus bx plus 15 is equal to 0. Now, if one of the roots is 3, when we say a root, it means that when you plug in that value inside this function, we need to get to be equal to 0. So I'm going to have 3 squared plus b times 3 plus 15 to be equal to 0. This is 9 plus 3b plus 15 is equal to 0. 3b is equal to 9 plus 15 is going to be 24. So this is actually going to give us minus 24. Divide 2 by 3, and this is supposed to be giving us minus 8 at the end of the day. So we get minus 8 because we are looking for the value of b. Good. That's 47. 48. Find the sum of the geometric series. Find the sum of geometric series. So we have so many ways of doing this, but I'll pick the short way. Right. So what can we do? We can say that summing from k is equal to 2 to 7, 4 to the power 3 to the power k minus 1. This is the same as, let's just plug in the values. So 4, 3 to the power 2 minus 1, 4, 3, 3 minus 1, 4, 3, 4 minus 1, 4, 3, 5 minus 1, 4, 3, 6 minus 1, 4, 3, 7 minus 1. If we're using calculator, you can just point it straight on the calculator and you get the final solution, because this is all finite values, right? So what I'm going to get is, I'm going to get something like this: 4 times 3, 4 times 3 squared, 4 times 3 cubed. Let me put it inside. 4 times 3 to the power 4, 4 times 3 to the power 5, 4 times 3 to the power 6, right? Then what can I do? I can factor all the 4 out. I'll have 3 plus 3 squared plus, is it supposed to be squared? Yeah, this one's supposed to be squared. 3 cubed plus 3 to the power 4, 3 to the power 5 plus 3 to the power 6. I'm so tired, that's why I'm writing like that. So what am I going to get? This is a geometric series, right? So since I'm doing the sum, I'm going to use the formula, what is a r to the power n minus 1 divided by r minus 1. What is my a? My a is the first term, what is 3? What is my r? This divided by this is 3, this divided by this is 3, so r will be equal to 3. So let's plug them in. 4 times 3 r to the power 3 minus 1 divided by 3 minus 1. So no, n is supposed to be 6. Oops, n is supposed to be 6 here. So we are going to have 4 times 3, 6, 3 to the power 6 supposed to be 729 minus 1 divided by 2. And we can do justice to that. Everything will be 4. 3 times. When I subtract 1 from this, this one will be left with 728, and divided by 2, I'm going to have something which is better. Okay, maybe I can leave this one by 728 and divide the 4 by 2. So I divide this one by 2, I get something like this, and multiply everything together, and I need to have 4368. So when you point it straight from the calculator, this is the final result that you need to get, which is right here, like D here. Good. So these are good for when you are doing written, right? But when it is objectives, always you pick the smart move using calculators and then checking if it is true. Now, if b squared minus 4ac is equal to minus 9, what can be said about the root of the quadratic equation this? So since they've given us something like this, what you can do is we can pick the functions to work on it. So let's see. If I want to find a quadratic formula, right, like the function, we know that quadratic formula is minus b plus or minus 4 b squared minus 4ac divided by 2a, right? But fortunate for us, the one under the root here is this, which is equal to minus 9. So I'm going to have minus b plus or minus root of minus 9 divided by 2a. But we know that root of minus 9 is going to give us minus 3i, which is imaginary, right? So because this is imaginary, it means that our function here is going to be imaginary. So it's supposed to give us day. Let's look at question 50. So which equation is equivalent to this one here? So, remember what we can do. We can do something which is very simple. Picking cos squared theta plus sine squared theta is equal to 1. What I can do is I can divide this one by sine squared theta, divide sine squared divided by squared theta. Now somebody is, why am I dividing 2 by sine but not cos? Because when I divide by cos, I know that sine over cos should give me tan, right? So you let me finish and we do that one too. So cos divided by sine is cotan, right? Cotangent. So since it's cos, we are going to have cos squared theta plus sine cancel sine, which is 1, and 1 over sine is sec. I said sec, cosec, so cosec squared theta, which is right here. But let's divide it by cos. When I divide everything by cos, here will be 1 cos over sine over cos is going to give us tan squared theta, and the 1 over cos is going to give us sec squared theta, right? Look at what is here. If I move this one here and move this one here, you see that this become minus when it comes here, and this one become minus when it comes here, but this is not minus, so it's not going to work out from there. So the only option is this, dividing 2 by sine. 50. 10 more to go. 10 more to go. Let's look at question 50. We want to find the sum of arithmetic progression here. This question here. So what can we do? Let's pick our a. A is equal to minus 5. So the sum, let's check for common difference and see if it's going to work out. So 2 minus 5 is 3. 1 minus 2 is 3. 4 minus 1 is 3. 7 minus 4 is also 3. So our D is 3. Good. Now we know that UN is equal to I think A plus is it N minus 1? Just thinking about this. We have N minus 1 D. Right. N minus 1 D. So what are we going to do? This will be UN to be equal to minus 5. When I put the 3 here, this will be 2D. I'll just come and check something. So when we are doing the sum, we know that the sum, since this is how many terms, 1 2 3 4 5, so when we start from 0, we are actually going to get, so this is going to be, the sum will be equal to summing k is equal to 0 up to 4, because when you start from 0, it's like 4, and this one is going to be UK. So I'm just representing, since this one is k, I'm representing the sub by k, and this is going to give us summing k is equal to 0 for minus 5 plus Oh, oops. I think this one's supposed to be okay, so let me use this one. This one is supposed to be, the d is supposed to be 3. So this one's supposed to be, when I multiply 2, I'm supposed to get 3n minus 3. And when I do that, I should get something like minus 8 plus 3n. Good, sorry. N is supposed to be 3. So I plug it in. So when I do that, and then since now my k the same as n, this one will change. So I'm going to have minus 8 plus 3k. Do you have it there? No. So if this is not there, then the option that they used was no subtractions. So instead of doing the subtraction, no subtraction from the other one. So we are going to have un to be equal to a plus nd, so that this will be minus 5 plus 3n, because d is this, so that now when you plug it in, this one now becomes minus 5. Yeah, and of course this is going to give us a right here. So some of the formulas, they are a lot, so when you get missing, you get missing. All right, let's look at 52. 8 more to go. Which quadratic equation has roots that have sum of minus 12 and product of 32? Right. So what we need to do is we want to find the quadratic equation. So sum is equal to minus b over a, right? So, and this is supposed to be equal to minus 12. Product is equal to c over a, and this one is supposed to be equal to 32. So from here, what we can do is the equation becomes minus b is equal to minus 12a, divide 2 by minus, this is like 12a. This one will be c is equal to 32a. Right. So this is what we are going to get. Divide 2 by, okay, so that's what you are going to get for b, c there. But we know that even very short way, the short way that we can do is, even without even solving this one, I think we have a formula that says that x squared minus the sum of roots, or x plus the product of roots. I think this is the short way. So x squared minus, what's the sum of roots? Sum of root was minus 12. So minus 12 x plus the product of root was 32. So 32. So when I do that, I get x squared plus 12x plus 32. This is very simple and very short for us to even see this. Right, so which one is going to be the best one to choose? C. So this is what you just need to know. Formulas are very, very key in Math 101. Let's look at this function right here and see what we can do. So this function here, 2x over x minus 2 minus 1 less than 1 over x minus 2. Here we can find something like LCM, and we are going to have something like this. X minus 2, 2x minus x minus 2 by finding LCM less than 1 over x minus 2. Simplify the top and we get something like x. No, this one's supposed to be plus, so plus, good. So you get 3x minus 2 divided by x minus 2. Now what can we do? Instead of here, instead of doing cross multiplication, this will multiply this, and then this will also multiply this. Yeah, I think that's what's supposed to be, this multiply that. So let's see what you are going to get. 3x minus 2, x minus 2 is less than x minus 2. Good. So what I'm going to do is very simple. I just move this guy here. So instead of x minus 2, I move this guy here, become minus x minus 2 less than 0. So I have x minus 2 here. I can factor it out. So x minus 2 out. What we left? 3x minus 2. What we left here? Minus 1 less than 0. So I have x minus 2, and this one will be 3x minus 3. So x minus 2 is less than 0, x is less than 2, 3x minus is less than 0, 3, no, x is less than 3, I think so. No, it's supposed to be 1, yeah, I think, good, 1. So let's try and pick it on the normal line, 1, 2. What happens? Plug in minus 1 here, minus 1, this one will be minus, minus 1, this one will be minus, positive is not less than 0. We can pick like something like 1.5. 1.5 here will be minus, 1.5 here will be positive. So minus positive will be less than this. 3 here will be positive, 3 here will be positive. There's no way positive is less than that. So the solution should be lying between 1 and 2, 1 and 2. 1 and 2, and this is supposed to be given as C. Okay, let's look at 54. So 54, actually what we can do is we can just do the idea of you just doing direct substitution or so, and then you are done, right? So what can we do? We can pick any of the expression and we just, so which of the following would you give to the fifth term of the sequence? Like something like that. So what is A? A is equal to minus 10. Is a common difference. Let me see. This, right, minus this is going to be 5. This minus is good. Okay, so D2 will be 5. So U15 is going to be A plus 14D. So how? They didn't solve the thing. Okay, so we just need the formula. Okay, so we know that. So this one is just asking for the formula here. I think so. So if that's the case, then the answer is supposed to be C, because we know that this one should be UN should be equal to A plus N minus 1 D, yeah, something like that. So since we have common difference and then we have our first term, we can use the C to do the calculation or the expression. But at least you should have put in like 15 here, and this one should be 4. Okay. Okay. Let's move on to the next question. 55. What is the seventh term for the sequence of the following recursive function here? So okay, so we want the seventh term. So what you can do is, since we have this minus 1 is equal to 2an minus 3, we have a1, right? So what you can do is we can start with when n is equal to, so actually this one is supposed to be 1. Yes. It's supposed to be plus, not minus. So when n is 1, we get a2 to be equal to 2a1 minus 3. So this is like, I have a1 here, plug it in, you get 40 minus this will be 37. Then A3 will be 2, A2 minus 3. 37 times 2 minus this one will give us 71. A4 in that order up to A7. And when you do that, you are going to have 2 times A6 minus 3. A6 is 547 minus 3, and this will be 1091. So you need to do it and using them to solve the other one. So this one's supposed to be the 1091. Good. What is the domain of this function? So with the domain, what we are interested in is we are interested in the one with the radical, because this is like a polynomial function. So the domain there, 4 minus x should be greater than or equal to 0. So x, well, let's say 4 should be greater than or equal to x. This is the same as x is less than or equal to 4. Right. So the answer is supposed to be C here. That's the domain. Okay, let's look at 57. 7, we have which of the following is false about acute angle? So this is equal to this. Yes, it's true, because this is going to be, when I expand this one, I'm going to have cos 90 sine 90, right? Plus no, this is going to cos 90 cos 90 cos theta plus sine 90 sine 90. So cos 90 is 0, sine 90 is 1, so it will be left with this, right? Good. Let's look at the C here. This is sine 90 cos theta minus cos 90 cos 90 sine theta. So this will be 0. This is 1, which will be left with cos theta, which is true. Let's look at this one. Okay, so this one is what we did, and we had sine. So it's not supposed to be minus. It's supposed to be sine. So the answer here is supposed to be B, because cos 90 will go to 0, and sine 90 is 1. So it will be left with sine theta, because this and this are the same. So the answer is supposed to be that one. 58. We want to add this one as a product. So we know that if I have cos of A minus cos of B, this is the same as minus 2 sine of A plus B divided by 2, and then sine of A minus B, yes, divided by 2. So this is what I have. So like this is my A and this is my B. So we just plug them in. So minus 2 sine A plus B. This is my A, this is my B. So I'm going to have 70 divided by 2. Then this minus this is going to give us minus 3t divided by 2, right? But sine is an odd function, so the minus can come out and make this one positive. So I'm going to have 2 sine 70 over 2 sine of 3t over 2. So my answer is supposed to be D right here. So odd function, if I have sine of minus x, it's the same as minus sine of x. So that is the idea. Okay, let's look at this. What will be the solution of this equation? So I have these two equations here. Let me see how I'm going to solve this. So I have x plus by is equal to a minus b. Let's say equation 1. And then bx minus ay is equal to a plus b. Let's say equation 2. So let's add equation 1 to equation 2. What are we going to get? Ax plus bx plus by minus, so like this is equation 1, this is equation 2. Let's add them together. We are going to have, when we add this one is going to be 2a, right? So this is going to be something like a plus b x out plus b minus a y out, which is going to be 2a. Now this equation is going to be true when x is 1 and y is negative 1. I think so. So that when I plug in 1, I get a plus b. When this is minus, I'm going to have something like, when I multiply 2 by minus, I'm going to have minus b plus a. This cancel this. Oh no, this one cancel this. Then a plus a was this. Good. So I think the option is supposed to be this. So the only way that you can also see is like you are just plugging in x values and this value. So when x is 1, right, and y is minus 1, you get a minus b. And the same thing for this one too as well. Yeah. So it's kind of just do substitution, just go. For what values or for what value or values of a does the quadratic function have a minimum value of minus 5? So we can just use this formula. The minimum value is like minus b over 2a. Right. So the minimum value here is minus 5. So minus 5 should be equal to, we know b to be 3. So we have minus 3 divided by, we don't know a, so 2a. Multiply, you have minus 10, a is equal to minus 3. Divide 2 by minus 10, you get 3 divided by 10. And we don't have 3 divided by 10. So there is no options. All right, so this is the end of the video. I know this is so long, I'm even tired, but thank you for joining us too. I'm going to the next video, I'm going to also release, a full question on start 101, introduction to probability, how you can go through and make sure that you do it and you do it well. All right, see you in the next video, and I wish you all the best in your exams.